From the Team Griffin Labs, we introduce you multiscale, self-updating causal networks for human disease. Problem: the longevity research ecosystem is very fragmented and overwhelming. For the age-related disease Alzheimer's, we have over 75,000 intervention studies, and that's only one disease, and there are hundreds of new longevity papers released every single week. These disorders, age-related disorders and longevity processes, have a multiscale nature which spans the molecular, cellular, and behavioral level, each with its different constraints and methodologies. For Alzheimer's, for example, the disease manifests itself at the gut microbiome level, the DNA level, and the tissue level with vascular mechanism change. There are significant bottlenecks in trying to achieve such a multiscale model because it requires enormous manual labor to parse and integrate all of these studies into one singular framework. And let's say once we put out the effort to go manually through all of these papers and integrate them into a single model, by the time we're done, a lot of new research emerged in the meantime, and much of what we built is deprecated, and we need to start all over again. The bottom line is, unlocking and unifying this multiscale data would dramatically accelerate discovery across the longevity industry. Our solution to this problem are AI agents for self-updating causal networks. The general workflow looks like this. We have someone interested in a disease, a supplement, a protocol. It feeds its interest to our agentic AI pipeline, which generates search queries, checks the relevance of the studies found, and extracts the causal effects. And once that's done, it updates a visual representation of the causal network about the phenomenon of interest. And then the person can play with the network and simulate interventions and see the larger network effects. To show in practice how this looks, we have two modules. First, the network building module, in which we feed in variable of interest, let's say vitamin D, how many interactions we want. We start scraping with our AI agents. We can also see the logs of our agents, evaluating the different papers, coming up with different queries, and extracting the causal effects. And we end up with a nice table providing us the variables of interest, what they influence, and what kind of interactions they have, plus a reference to the peer-reviewed paper from which it was extracted. Now, once we have a graph extracted, what we can do is go to our network visualization and simulation module, in which we can have our variable of interest, let's say exercise, and we are curious what's going to happen if we increase exercise. We apply our intervention, and what we see are the network effects, color-coded by the red and green dots. So if we increase our exercise, our muscle mass increases, which leads to higher glucose uptake and higher metabolic rate. And also it leads to lower body fat, which leads to lower inflammation, which leads to lower joint pain. This is the general network. These are three networks that can be generated with our model, ranging from workout protocols to age-related diseases to exercise and nutrition. Now moving on to the monetization potential here. What we're doing here has frictionless deployment. We offer a web-based platform with simple access and no complex setup that anyone can use given the login details. An opportunity is co-developing with pharmaceutical companies and earning profit shares from the drugs they develop with our using our platform. We can also offer lifestyle optimization services for wellness companies to personalize, or say to consumers to personalize and visualize network effects of potential interventions they want to include in their life. And also another interesting avenue is making an investor intelligence tool that offers a neutral analytics platform that helps investors evaluate the biotech pitches and verify that their off-target risks are properly addressed. Now, we made sure that there's actual use for this by performing customer interviews, and we received 2 letters of intent from reputable companies in the biotech sphere, from Rejuve.bio and from Tract Biotechnologies. And this is our team. This is me, Andrei Alexandru, who took care of the vision and the conceptual framework. This is my associate, Elias Lee, who worked only temporarily on this project and was in charge of the AI agent implementation and optimization. It's been amazing working on this hackathon. Bye.